All, Vinod here from Entrance Engineering Academy. Before going into the video, I just want to say a few things about Entrance Engineering Academy. So, EEA is an online gate preparation portal, and we offer full course for GATE ME and XE. In addition to that, subject courses are also available for ME, XE, CE, and PI. Engineering mathematics course is available for all stream, and in addition to that, we offer online test series for GATE ME and XE also. So this is our website. You can just check out so that you will get to know more about us. And in addition, we have our own Android app and also iOS app, and you can just go through that also to know more about our courses. Okay. And this is our last year, that is GATE 2021 result from XE. And now let us proceed to the video. And this video is taken from online video course of Endurance Engineering Academy. So let us start our next chapter. So in the first chapter, first what we did, I given you an introduction about engineering mechanics and in general about physics and mechanics, all those things. That is what I did initially. And then we seen why we need to assume, okay, what is the advantage of assumption or idealization. And by starting the first chapter itself, we assumed many things. What are the things which we assumed? We assumed that it is kinematics. Kinematics means what? Motion will happen, but we are not going to consider the cause of the motion. Okay, the force which is acting on the body is not considered. Okay, and in the first chapter we had another assumption that I am going to treat it as a particle. What does it mean by a particle? Even if the body is this much size or very big, it may be car or it may be bus or whatever it is, I'm going to treat that as a single point. Okay, and under what assumption or under what condition we assumed it? If range of motion is comparatively very high, like if range of motion is very high compared with size of the body, if size of the body is very small and if range is very high, I given you some example also traveling from Chennai to Delhi and all those things. Okay, so if I travel from Chennai to Delhi, the train will be considered as a point only, or the plane will be considered as a point only. So that point or the complete body is to be treated as a particle. So in the first chapter, we assumed it is kinematics, we assumed it is particle, and also we assumed the motion is happening in plane only. What does it mean by motion happening in plane? The motion is going to happen in two-dimensional only. It's not going to be third dimension. It's not involving any third dimension. So either it can transfer like this, or it can transfer like this, or it can rotate. Okay, like but in the planar motion only, XY plane only. Right. Now, under what condition we assumed it to be particle? The one condition is very simple. We are going to assume it. We assumed it that range of motion is very high compared to size of the particle. The second condition, just by reading the question, see, for example, if they are giving you a car is moving in this direction, blah blah blah, etc. And how to assume, how to finalize that? In the question they are assuming that the car is a particle. How to finalize it? Simple. If dimensions of the body, okay, so they given car is traveling, etc., blah blah blah, and if that car's dimension is not mentioned separately, okay, if the dimension of the car is not mentioned separately, then they are asking us to consider the car as a particle or nothing but we are going to deal with particles only. Okay, so we are going to treat that body as a particle. Now, second chapter, we done all those things, right? We dealt with all the parameters, motion parameters such as velocity, acceleration, displacements, angular velocity, angular acceleration, circular motion, and the linear motion, all those things in detail. Now coming to next chapter, here we are going to deal with kinematics only. Here also it is kinematics. Okay, kinematics, we are not going to consider the cause of motion. And here it is rigid body. Okay, we already know what is mean by rigid body. If I take any 2 points in a body and if the distance between those 2 points doesn't change, even though after applying different amount of forces, I can treat that body as a rigid body. And in a plane motion, again we are considering the rigid body to be in plane only. Okay, so that is two-dimensional only. There is no third dimension perpendicular to the board, right? Now, so the motion will happen in the plane, in a single plane only. Okay, right. Now coming to rigid body, like again, how you will find out this particular problem belongs to rigid body? How you will find out that this is not belonging to a particle? How you will find out? Simple. the dimensions of the rigid body will be given in the question. If it is given in the question, then the problem belongs to rigid body case. Okay, right, now coming to the things what we are going to do first. See, if I take some rigid body, for example, let me assume that this is my rigid body. Let's assume this is our rigid body. Okay, so if the rigid body is moving in a plane, how it will move? For example, let us consider this is the some general motion. Okay, initially my rigid body was here, it is moving like this. Okay, so initially my rigid body was here, it's moving like this. Okay, so let us consider there is a rigid body. Okay, so it is moving, it's moving, it's moving, it reached here. Okay, now just recollect something. In case of particles, what we did, if there was a total body also, even if it is a car also, we will consider it to be a point only, and that point is nothing but center of gravity. So, but in case of rigid body, we cannot do that. If you take rigid body here, this single rigid body has, you just consider this single rigid body has n number of points, right? This single rigid body has n number of points. For example, let us consider this is P1, okay, P2, P3, there is another point here, P4, another point here, P5, P6, or else let it be until P5. Okay, so totally there are 5, like I'm just considering 5 points, but there will be n number of points, right? Let me just mark it out, n number of points. Each and every space has different points. And now if this rigid body moves in a plane, in general, if a particle moves, there will be only one particle, happily it will move, we can easily analyze it. But here there are n number of points in a single body itself. And if this rigid body moves, okay, if this rigid body moves in a plane, how it will look? Simply let us consider like this. Okay, it's moving like this. Okay, it's moving like this and it is reaching here. Okay, it is reaching this position. Okay, just consider this body has traveled like this. Now consider particle 1. Okay, particle 1. What happened to particle 1? It traveled like this, right? And what about particle 2? It traveled like this. And what about the particle 3? It traveled like this. Okay, here. Okay, and particle 4 similarly, just approximating, yeah, and particle n here. Okay, so initially these are the positions of the particle. After this total rigid body moves like this, each particle has transferred or has traveled some distance, right? Now these are the new position of the particle. You could see this is, let me take it as P1 dash, and this will be my P2 dash, and this is my P4 dash, just approximately marking it. Okay, so this is my P3 dash and this is Pn dash. So similarly, each and every point in this rigid body was traveling or was transversing some distance when the rigid body moves. So now, which point I need to consider for doing the analysis? That is something which we cannot answer straightforward, because each point travels different distance and each point rotates also. You could clearly see what is actually happening to, let us consider point P. What is actually happening to point P? Happily it is translating. Translation motion is there. In addition to translation motion, it is rotating also, right? You could see it is rotating also, right? It is rotating also, it is rotating also. It is not only translation, it is rotation also. Okay, so it is translating and also it is rotating, each and every particle. Few particles there is a possibility, there is a few points there is a possibility that it will only translate, but here for the example which I am considering both translation is also happening and rotation is also happening. Okay, translation and also rotation. Now these are the two basic motions of rigid body. Okay, one is translation, another one is rotation. Now if I want to consider a general motion, this is the general motion which includes translation also, it includes rotation also, it is combined. Okay, so that is something called as a general motion or random motion or combined motion. Why it is combined? Because it includes both translation and rotation. As you could see here, when it is moving, this body moving from here to here, It is translating and also it is rotating, so it involves both translation and rotation. Okay, so that is why this motion is general motion. Now coming to a question, how to analyze this, how to find out the parameters, velocity, acceleration, angular velocity, angular acceleration, etc. How to do that? There are two ways. One is again the way which is developed by Newton, and another one is the way which is developed by Euler or Euler. Okay, so first we are going to start with Newton's approach. Again, same, not the same as that of particle. Here also he is going to use the same technique. What actually in particles Newton did, divide and rule, right? He asked us to find out all the data for x-axis and all the data for y-axis, then analyze x-axis separately, analyze y-axis separately, finally find out the resultant, right? By combining those two, find out the resultant. Similarly, here also Newton is going to define two simple motion and combine those two simple motion to get the final motion. And those two simple motions which we already know, one simple motion is translation, another one is rotation. Pure translation, pure rotation. Okay, if pure translation means the body is only translating, rotation means the body is only rotating. We will talk about that in detail later. First understand this. So what Newton is going to do, what Newton did, he simply defined two simple motion, one translation, rotation, and he combined these two to give a result for general. And what Euler did, we will see later. It is an instantaneous center approach. We will see that later. So first we will define what is mean by pure translation and pure rotation. Then we will combine it so that we can see what is Newton's approach, and we will go for Euler's approach. So let us understand what is mean by pure translation. See, what actually Newton is going to do, as we seen that general motion is going to happen. Like general motion means what? Suppose if this is the body, if this is the body, a body can travel like this. Okay, in general it can travel. If it moves like this, then it has both rotation and also it has translation. So what Newton is going to do, simply he is going to split it. Okay, whatever may be the general motion, he is going to split it into pure translation and pure rotation separately. So two simple motion, pure translation motion and pure rotation motion, these are the two simple motions which we are going to study first. Then we will combine it and we will study a general motion or combined motion or complex motion, whatever the name you need to call it. Okay. Now first pure translation. Suppose this is the body. Okay, let us consider our duster itself. This is the body. The body is just moving like this. The body is just moving like this. Okay, the body is just moving like this. Okay, in this particular body, I am taking 4 different points. You see, there will be n number of points. Okay, just for explaining purpose, I am taking 4 points, but there will be n number of points. Okay, so I am taking 4 points, and when this body is moving, all these 4 points will be moving in this direction. Am I right? So just all the 4 points will be moving, right? Now, when I can call it to be pure translation, simple. When each and every point in the rigid body, okay, when each and every point in the rigid body covers, or each and every point undergoes same linear displacement, or each and every point covers same distance, okay, then I can say the translation to be or whatever the motion to be pure translation. It indirectly means what? Initially, the initial position of, you could see that initial position of P, this is the initial position P1, P2, P3, P4. After undergoing this motion, okay, so this is undergoing a motion like this. After undergoing a motion, this is the new position of P1, P1 dash, P2 dash, P3 dash, P4 dash. These are the new position. So the distance or the displacement or the linear displacement this particular point covered was L1. Okay, so which is nothing but P1 dash, and similarly L2 is the distance covered by P2, L3 is the distance covered by P3, L4 is the distance covered by P4, or in other words linear displacement. And when can I say it to be pure translation? When these linear displacements are same, which is equal to Ln. Ln means you can take a point here Pn, it covers Pn dash. Okay, so n number of points. Similarly, I can write it in other words, P1 dash is equal to P2 dash, which is equal to P3 dash, until Pn dash. Okay, so what is the definition of pure translation? Simply, if each and every point in a rigid body covers same linear displacement, equal linear displacement, I can call that the motion to be pure translation. Okay, Now, what are the other extensions which I can make here? There are few extensions which I can make. The first extension is, listen carefully, this particle P1, listen carefully, okay, this is the first extension or the first condition, okay, under pure translation. The first condition was L1 is equal to L2 is equal to L3 is equal to Ln. What it says, equal or same linear displacement. Each and every point will have same linear displacement in the body. Okay, that is, each and every point in the body will have equal and same linear displacement. Now coming to second point, this point P1 covers distance L1. Let us consider it covers the distance L1 at a time period t. Okay. Now what about this point P2? At what time P2 is covering distance L2? Obviously at the same time only, right? I'm just moving it, you could see it, you could clearly see. I'm just moving this body from here to here. Okay, maybe 5 seconds or maybe 10 seconds. So for that time period, the same time period only, P2 is also covering distance L2. And similarly, for the same time period only, P3 is covering distance L3, and for the same time period only, Pn is covering distance Ln, P4 is covering distance L4. So what does it mean? Each and every point in our body is covering equal linear displacement in the same time. So what I can conclude? What is rate of change of linear displacement? Rate of change of linear displacement is nothing but our linear velocity. I am stressing the word linear because we are dealing only with translations. We are not dealing with rotations. Okay, when I am go to rotation, I will talk about angular. Okay, right. So what is the second point? Very simple. Why it is actually happening? Each and every point in our body is covering equal distance in equal time. Okay, so L1 amount of distance is covered in t time. Similarly, the same distance each and every point is covering at the same time. So linear velocities of each and every point will be same, which means V1 will be equal to V2 will be equal to V3 will be equal to Vn. So velocity of this particle, that is point, velocity of this point, all the points in the body will be same. Okay, so same linear velocity. See, this is not a separate condition. This is something which we are getting due to this condition. Okay, due to first condition only we are getting it. Okay, right. Now third one, listen. If this particle, let us assume it is traveling at some speed of 2 meter per second square, okay, that is at an acceleration of 2 meter per second square, and if this particle is moving at some 5 meter per second square, will it happen or can it happen? One particle is moving at 2 meter per second square, another particle is moving at 5 meter per second square. What is actually acceleration indicating? Rate of change of velocity. Okay, if this acceleration changes for different particle, then increase in the velocity will also vary. For example, this particle, okay, point, okay, this point P1 will increase its speed at a rate of 2 meter per second square. That is as you could see that the velocity will be increasing at a rate of 2 meter per second square, okay, like lesser rate. But this point will increase the velocity at a rate of 5 meter per second square. That is, it is increasing the velocity at a more rate, at a faster rate. So obviously, if it happens, if the acceleration of this particle is less than that of acceleration of this particle, then this particle's velocity will vary with respect to this particle's velocity. I hope it is clear, right? So if acceleration of different particles I'm very sorry, I'm using the word particle, it is point, okay? So if acceleration of different points are different, okay, if acceleration of different points in a body is different, then velocity will also start varying, okay? That is, one point velocity will vary at a faster rate, another point velocity will vary at a slower rate, another point will be very slow, another point there won't be variation in velocity at all. For example, this 3, okay, it's moving at 0 meter per second, acceleration was 0, which means point 3 is not increasing its velocity, it is moving at a constant velocity. But point 2 is increasing velocity at a higher rate. Point 2, it is increasing velocity but at a lower rate. So three points will vary its velocity. The velocity is not going to same. All 3 different points will have different velocity. But we already know for pure translation, linear velocity has to be same. So obviously this is not possible, which means each and every point in the rigid body, if it has to undergo pure translation, okay, if it has to undergo pure translation, then acceleration should also be same. Okay, that is the third condition. Why it is happening? Just now I explained. If acceleration varies, then rate of velocity variation will also vary. So each point will have different velocity. It is violating the pure translation condition. So third point, A1 is equal to A2, which is equal to A3 until AN. So same linear acceleration. See, in general, we will use acceleration, velocity, displacement only. But I am stressing the word linear because we are dealing with translation. Once we go into what is that, rotation, when there was angular displacement, there everything will become angular. Okay, so that is why I am specifically mentioning the word linear. Now coming to the final point. Okay, so these are the three things or three outcomes or conclusions of pure translation. This is basic definition. Okay, basic definition of linear displacement, basic definition of pure translation is what? Linear displacement of each and every point in the rigid body should be same. Okay, now next, because of that velocity is also becoming same, linear velocity, and because of that linear acceleration is also becoming same. Now, so each and every point in a rigid body, if it undergoes pure translation, has same motion parameters, right? Under linear motion, it is having same motion parameters, that is displacement, velocity, acceleration, all three are going to be same only. So instead of taking each and every point for pure translation, what I can do, suppose if this is the body, anyways each and every point, okay, anyways each and every point is going to have same velocity, same acceleration, same displacement. So I can define the motion of this body, with respect to center of gravity itself. Okay, just if you define displacement, velocity and acceleration of center of gravity, obviously all the other points in the body will also have same displacement, same velocity, same acceleration if it undergoes pure translation. Okay, I hope it is clear. So under pure translation, since all point in the body has same displacement, same linear velocity, same acceleration, so simply I can use center of gravity for specifying the body, and if I, whatever the value the center of gravity is going to carry, whatever the value of displacement, whatever the value of velocity, whatever the value of acceleration the center of gravity is going to carry, that same value only all the points in the body will also have. Okay, so now let us proceed to pure rotation.